Welcome. This is Odumat. Today I want us to look at calculus, and under calculus we are looking at rules of differentiation, and under that we are concentrating on differentiation of function of a function, or the chain rule. Okay. Now let's look at this. If f and g are differentiable, if f and g are differentiable, and f is equal to f of g of x, what we call fork, and this composite function, okay, f of g of x, defined by f of x equals f of g of x, then the f prime differential, the differentiation of x and f of x becomes f prime of g of x, the f prime of g of x, then times g prime of x. Okay, so in Leibniz notation, or in Leibniz notation, dy dx, that's the same as this one, is equal to dy du times du dx. So we call this the chain rule. Okay, so we can simply say that y is f of u, and then u is g of x. And let me conclude, let me rewrite the notation again. So dy dx becomes dy du times du dx. So again, pay attention to the formula. So for chain rule, it's also nothing. It's no problem. So let's look at some examples. Okay, so given this problem here, we are told that we should find dy dx if y is equal to square root of x squared plus 1. Okay, now we can rewrite this in another form. So my y equals square root of x squared plus 1 can also be the same as y equals, into brackets, x squared plus 1 to the power half, because square root, so to the power half. Okay, then we let u be equal to what is in the brackets, so that is x squared plus 1. So it means that our y is equal to u to the power half, because we said let all this be represented by u, so u to the power half, that is y, and u is what's in the brackets. Okay, so our du dx becomes, this one becomes 2x. Then when we come here, our dy du becomes 1 over 2u, then to the negative half. That is, when you subtract 1 from this, you are going to get negative half. So this half should multiply this. The rule says that. Okay, so now let's continue. So my dy dx, which is dy du times du dx. So I'm just going to substitute. So my dy du, I had 1 over 2u to the negative half, times du dx, I had 2x. So I can multiply this. So now this and this can be 1 over 2 times 2, this 2, then u to the negative half, also multiplied by x. So this will take care of this one. So we have u, 1 times u is, so u to the power negative half times x. Okay, but our u has been defined already as what is in the bracket, that is x squared plus 1. So we have the answer to be, the dy dx to be, into brackets, x squared plus 1 raised to the power negative half times x, times this x, and thus having a negative power, so we can rewrite this as x over square root of x squared plus 1 as our answer, because this is having a negative power, and anything raised to the power half is a square root of that. Okay, So x having a positive power means it should be a numerator, it should be a numerator, and then this becoming a denominator as this. So now let's solve these examples. We have to find dy dx when this is given. Okay, so the first one, y is equal to, here I am taking you through first, second, and third, and then you will do this one on your own. Okay, so the first one, y is equal to 2x plus 3 all to the power 5. Okay, so here we let what is in the brackets to be u. So let u be equal to 2x plus 3. Then this means that my du dx becomes 2. Then my y is now u to the power 5. So in this case, because I said what is in the bracket should be u. Okay, so in this case, my dy du becomes 5u to the power 4. That is, this time this 5u, then you take one from this, that is 4. Okay, so my dy dx, which is equal to dy du times du dx. That is, when you cancel this, you get dy dx. Okay, so my dy dx, now my dy du, I had 5u to the power 4 times du dx, I had 2 times 2. So this and this becomes 10u to the power 4. But u is 2x plus 3. So in this case, my dy dx becomes 10 into bracket 2x plus 3 to the power 4. Okay, so we let the second example, we let that's this one, we let u to be equal to what is in the brackets. So that is 2x squared minus 5x. Then in this case, our du dx becomes 4x minus 5. So this and this is 4x, and then this will be negative 5, so 4x minus 5. So in that sense, our y is equal to u to the power 2. So dy du becomes 2u. Okay, so in this sense, the final answer, dy dx, which is equal to dy du times du dx. So my dy dx, dy du, I had 2u, so 2u times du dx, I had 4x minus 5, so into brackets 4x minus 5. But my u is equal to 2x squared minus 5x. Okay, so I'm now going to have 2 into brackets 2x squared minus 5x, then times 4x minus 5. Okay, so this is going to be 2 multiplying this will become 4x squared minus 10x, also to multiply 4x minus 5. So this will be, this and this becomes 16x cubed. This and this one becomes minus 40x squared. Then this and this one becomes minus 20x squared. And then this and this one becomes plus 50x. So in simplifying this, I have 16x cubed. And then this and this will give me minus 60x squared plus. Okay, so for the third example, we let u equals what's in the bracket, x squared plus 2. So my du dx becomes 2x. Then if u is equal to x squared plus 2, then it means my y is equal to u to the power 3. So dy du becomes 3u squared. Okay, so my dy dx is now dy du times du dx. Okay, so my dy dx, my dy du is 3u squared. 3u squared times du dx. I had 2x. So 2x. So this is but u is equal to x squared plus 2. So 3 into brackets. So let me multiply this, and this becomes 6, then into brackets u, which is x squared plus 2 to the power 2 times x. And we can still expand this. So this is 6 into bracket. This is going to be x cubed plus 2x. No, we cannot do because of this. So let me only multiply this and this. So 6x into brackets x squared plus 2 all to the power 2. Though we can do it, but when you end here, there wouldn't be any problem. Okay, we can expand this and then after multiply it with this one, or we just leave it as this. So thanks for watching. Please try to solve the last one, that is this one, on your own, and then send the answer put the answer on the comment section. I'll look at it and then reward you. Okay, please don't forget to subscribe, like and share this channel. The name has always been Odu Maths. Thanks for watching. Bye.